Alright, so today we're going to be graphing linear inequalities, and if you think about something that's linear, that means it makes a line. So we're going to be talking about inequalities, but inequalities that make a line. So you might remember like something like this, like x is less than 2, and I was telling you to graph that. It's been a while since we've done it, but you might remember it's 2, it's 3, 1, and you think about what type of circle you'd use here. You'd use an open circle for this one because there's no line underneath, and then you'd go less, which is to the left, all the numbers lesser, and that's how you'd graph it. But now we're going to be graphing things instead of in like, I guess, 2 dimensions or 1 dimension, left to right. Instead of just one axis to worry about, we're going to have both axes to worry about, the x and the y. So this is just the x-axis, and I took the y-axis out of it, but now we're going to have to do it in both. So we're going to make basically a line that is an inequality. So let's talk about it a little bit. So the things you want to kind of copy down right now are, we're graphing inequalities using the same rules we'd use to graph a line. So it's the same as graphing a line, okay? If you can graph something that's in y equals mx plus b, now all I'm asking you to do is to graph something that's y is greater than mx plus b. Or maybe y is less than or equal to mx plus b. So there are 2 extra rules. This is huge, okay? Fill in here. We need to understand that. Oops, my highlighter. I don't see it. Okay. When you have these types of symbols, you use a dotted line. This is kind of like an open circle. So open circle or a dotted line, they're kind of similar. So we have a line that looks like that. Okay, that's my best attempt at a dotted line. And when you have these right here, that would normally be a closed circle, and in this case you're going to use a solid line. So you can imagine like the dotted line, you're not including the line, right? The dotted line, you're not including the line. And with the open circle, you're not including the circle. So that's what's happening here. Okay, so this is what you want, a dotted line or a solid line. If there's a line underneath it, if there's a line, draw a line. If there's no line, it's dotted. Okay, second thing you need to remember is this. These are all the things you have to really understand. If you have a greater than or equal to, then you shade above the line. And what does that mean? I'll explain that in a second. And if you have a less than or equal to, then you shade below the line, okay? And this is really all you need to understand. So talk about those kind of things. So think about that for a second, and then let's just look at an example. See if we can put it into use, into practice. So here's an example. So let's go through it. So let's just think about this for a second. If we look at it, we see this symbol. Okay, it's in the right form. So for right now, we're going to have them all in the right form, y equals mx plus b form. But it's not going to be an equals, it's going to be something here. Okay, so I'll just put an equals for now. But you notice that there's this. So this is a greater than symbol, so we want to shade above the line. Above the line is the first thing. And do we want to use a dotted or solid? Well, because there's no line underneath, we want to use a dotted line. So we use a dotted line. Dotted line is kind of saying like, I don't want to include the line, but I want to go right up to it. Not including it, but right up to it. So let's look at what our m and our b are. What is our slope? Our slope is -3 over 1 if you like. And our b, or y-intercept, is -4. So as always, we just plot -4. We would go down 3 over 1, but we're running out of space, so down 3 over 1 would be somewhere around here. But instead I'm going to go up 3, and I'm going to go left 1. So that's still a negative slope. So instead of down 3 into the right 1, I go up 3 and left 1. I do that a couple times, and I now have what I need for a line. Now it needs to be dotted, so I'm going to go ahead and just go like this. Now I have my boundary. Now the question becomes, I need to shade above the line. So here's where something kind of cool comes in. What I want you to do is imagine that, just for a second, I'm going to erase this in a moment. I want you to imagine that this is a mountain, okay? It's a very steep mountain that you're hiking up, okay? So you can put your little man on it if you want, whatever. He's hiking up the mountain, okay? And then in addition to that, there's the sky, right? So this is the sky, right? And the sky is usually blue. So this is the sky. And you imagine this guy is hiking up the mountain. So the question becomes, where is above the line, right? So above the line is the sky. We want to shade above the line, we want to shade the sky. So imagine there's a man walking up the hill, and shading above is the sky. There's a couple things that can mess that up for you, but basically, that's what you need to understand. So if we're shading above, we want to shade all of this in. So you color it very lightly with your pencil. Okay, so go ahead and do that. And you'll just shade all of this in. But you won't shade anything over here. This is all everything above the line. Okay, so that's one example. So I just wanted to give you a quick understanding. Let's try to do another one. Oops, that's what you were filling in. Now there's this one. So let's talk about it. Let's just look at this as a normal line. So let's just talk about this. Well, it's a slope at negative, it starts at -1 and it goes up 1 over 2. If you have trouble with graphing lines, you're going to need to go back and look at what's going on here. Oh, before I do that, I need to think about whether it's dotted or solid. So that's the question. So I'm going to say solid. There's really only two things I need to know. Solid, and is it above or below? It's below the line because it's a less than symbol. This is a less than symbol. So y is less than or equal to, and I need to go below this. So I'm going to just make a solid line. So nothing's changed here. Now I need to shade below it. Well, imagine your man is walking up the mountain. Well, if your man is walking up the mountain, this is the sky, right? We have the sun over here. You can kind of see that. And so we know that below the line is going to be everything down here. So that's what you'll color in. Okay? Make sure your line goes all the way across. See how this is happening? We want to make sure that that line goes all the way across. And we want to color in all of this area. You don't have to color it crazy dark. Just make sure I know that it's colored in. It's shaded. So that's two quick examples. And I figure hopefully you're at a pretty good spot where you can try one. So let's go to the next page, and you flip the page, and you'll be here on this problem. Now you try this problem. So you graph this. Think about whether it's dotted or solid. That's one thing you got to consider. So is it dotted line or is it solid? And the kind of cool thing is the solid line makes you think of the filled in circle, and the dotted line makes you think of the open circle when you did the number lines. And then you need to think, is it above or below? Now this is all assuming that you understand how to graph a line. If you're good at graphing lines, then this is actually going to be a pretty simple section for you, because you just got to remember two things about this symbol right here. So make that decision and try this and do the best you can do, and then we'll go on. So pause the video, give it a shot. Okay. So these are the things you really need to remember, okay? If it looks like this, it's a greater than, and this is a less than, but these are solid lines because there's a line underneath. They're solid lines, okay? So just remember that these two are going to be a solid line. And then this one is a greater than, this is a less than, and this is going to be a dotted line. So we're showing you the different options. Of course, these two that say greater, you shade above. You shade the sky where the sun is. These are greater. And these are less. Now when I was in high school, I could never remember which one was a greater symbol and which one was a less symbol, because, but the idea is that if you put a number here, 5, and then you make the alligator eating the 5, if you've heard of that analogy, that's 5 is blank than 2, and it's greater than 2. And that's how you can remember it. I never got it all the time I was in high school, but finally figured it out. Okay, the other thing that we want to do is just talk about solutions to inequality. So this part right here is a recap. This is a review. You should already know how to do this. You take the x equals 3, right? And that's x, so we substitute it in for x. So if 12 is greater than 11, and we say yes or no, and I would say yes because that's true. And then I would take the 4, and I would plug that in for the y because y is equal to 4. So 16 is greater than or equal to 16. Well, is 16 greater than 16? No. But is 16 equal to 16? Yes. So it does satisfy. It still works out. But now what we're doing is we're taking it up one notch. So I'm going to change colors. And we're going to talk about the new type of thing. It's really just showing you that you have an ordered pair. You have an x and a y. So you have two things to plug in and see if it works. Not that big a deal, but something that we should at least talk about. So when we plug in the -1 here, so I'm going to plug in a -1 here, and I'll plug in a 9 here. Let's see what happens. So we have 2 times negative 1 plus the y, which is 9, is less than negative 3. So we have negative 2 plus 9 is less than negative 3, which would be 7 is less than negative 3, and that's a no. It's not true. So you just say yes or no, but you have to show the work to get there. You've got to show the work. So one more. Let's look at it again. X is going in here. This is X. We've got our Y value, which goes here. By the way, when you're drawing a diagram for wiring or like electrical, this is kind of funny. To show that those wires don't meet, you would make a little hump like this. So if you were going to like draw like a switch, like an outlet over here, I know I'm a little off tangent, but, and then you wanted another wire that was coming through here, but you didn't want it to touch that, you'd go like that. That's just another wire that like doesn't actually connect. But if you draw a wire like this, then it connects automatically. All right, anyways, so random stuff that you learned from me. So X is 2, so 2 minus 3 times Y, which was what, negative 2. And that should be greater than or equal to 8. That's supposed to come out blue. Well, it didn't come out blue, but probably just didn't choose blue, right? Okay, so let's do it out. We got 2 plus 6 is greater than or equal to 8. 8 is greater than or equal to 8, and I would say yes, that is true. So that's pretty much it. Pretty quick and easy video. I think it took us about 12 minutes just about. So take a second to try these two and tell whether they are a solution to the inequality. So you should have these two for your now you try, and the one on the previous page, the y is greater than 1/4 x plus 3. So come in with the notes done and come in with those problems tried, and we will talk in class soon. So pretty simple section. We just want to understand how to plug in and check it, and we want to understand the 2 rules for graphing for right now. And it will get more complicated, but nothing crazy. This isn't too bad of a section. I hope it goes well, and I will see you soon.